Today, let's go over a medium question that I just solved by myself. This one's called maximum increasing triplet value, and it's a pretty simple question that asks you to find the triplets that satisfy this condition. And so let's first come up with a brute force solution. So the index is less than, the values all less than from ascending order. No equals, so they all have to be less than each other. So easiest way to do this is to do a triple loop. So one starting in front of the other, so we satisfy the index requirement. And then also the value requirement needs to be checked. If that's the case, then we're looking for the biggest value, which is defined as nums of I minus nums of j plus nums of k. And then we can return result. This is technically working, but it's slow. Okay, as you can see, we need to come up with a better solution. So if you make some observations here, basically we want to find values to the left side and to the right side because of the index requirement. So if you know that, let's declare two sorted lists, lefts and rights. The rights is going to contain everything to the right, which is going to be everything in the first iteration. And then the lefts, we're slowly going to add the current element to it. So let's iterate over nums from left to right. Let's say lefts.add nums of I, rights.remove nums of I, because the right side not including, right? So let's print lefts and rights. Okay, as you can see. And let's also print the current value, which we'll call the j value, because the j is the guy in between. Nums of I. Okay, so now the real challenge is going to be, because we know this guy is always going to be used because it's we want to maximize this value and we're adding it, so take the biggest value if it's possible. But we also want to find a number that's smaller than the current j value that minimizes the difference. So 5 minus 6 is 5 is closest to 6, but also not equal to 6 in this left side list. That's the number we want to find. It's a bit confusing, but let's try to think about this. So we can run a bisect left to find the position where 6 goes, and then -1 to get the smaller element, because bisect left basically inserts it where it's first supposed to come. So 6 would be inserted at index 1. And then we only have a solution if both sides have elements because of this requirement, right? So let's do if lefts and rights. Then in that case, we can look for this value, like 5, which is going to be well, first of all, we want to make sure that lefts and rights are, so this is in between this list. So let's say if j value is bigger than lefts of 0 and j value is less than or equal to or less than rights of -1, then we can do the bisection, right? We're looking for a value that's smaller. And in that case, let's call this closest to, because that's what we're looking for, a j value that's closest to but less than. So then now we can run a bisect lefts on lefts, looking for this closest to value. Okay, so now that we have that, let's print b. So 1, cool, but we want 0, right? So let's call this b minus 1. That's what we actually want to subtract. So we're going to use the 0th index value to subtract from this one plus 9, right? So then now we can just say left side is equal to lefts of t minus closest to. And then we can say result is max of result and left side plus rights -1, because that's always going to be the biggest value, right? So then if we return this at the end, this should work. Okay, so let's declare a variable called result. We're looking for the maximum value, and that should work, except we got to get rid of the print statements. And also I wanted to address something. So here, there you go, accepted. So not the most efficient, but it gets over the time limit exceeded hump. If we get rid of this guy here, what's going to happen is if we're out of bounds, we're still going to calculate it, which is not correct because we have to make sure that the current J value is like within the range. It's not like bigger than, it's like within the bounds of lefts and rights. So if J value is bigger than left's 0 and J value is less than right's -1, that's the only way this is going to work. So let's do this. So if we run this, for example, let's print lefts and rights and nums of I, it's J value. So if, for example, we didn't have this check, J value is, if it's out of bounds, if it's less than the minimum, then we can't make this smaller than this, right? And if J value is, well, if it's bigger than rights of -1, then we can't go out of bounds because of the requirement here that's nums of J is less than nums of K, which is any value here. This cannot be smaller than the biggest value in here if this guy is like 10, for example, if J value is 10. So that's the only reason this was done, because of this requirement. So just wanted to clarify that. And other than that, thank you for watching and stay tuned for more.